All right, here's a problem that may be a little challenging. Let A be a 4 by 4 invertible matrix. Suppose that A inverse of times 1, 0, 2, 0 is equal to 2, 2, 1, 1, and A inverse times 0, 1, 0 minus 1 equals 3, 4, 0, 1. Find the solution to AX equals 4, 5, 8, minus 5. Now remember that this pertains to MINM competency 2, so you can take a look at that competency and see how that applies. And you can go ahead and pause the video and see how you want to do it, and then come back and we can do it together. All right, back so soon? Well, let's take a look. Now, any solution to AX equals 4, 5, 8, minus 5, that's true if and only if, because A is invertible, that's true if and only if X equals A inverse times 4, 5, 8, minus 5. Right? That's what the competency says. All right, so how are we going to find A inverse of 4, 5, 8, minus 5? Well, we have some information about A inverse. A inverse of 1, 0, 2, 0 is this. A inverse of 0, 1, 0, minus 1 is this. Now, if you take a look at this vector, 4, 5, 8, minus 5, I can assemble this vector from these two vectors fairly directly. That's equal to A inverse of, now, if you take the 4 and the 8 part, that's the same as 4 times 1, 0, 2, 0. And the 0, 5, 0, minus 5 part is the same as 5 times 0, 1, 0, minus 1. Okay. So you can see that if you form this linear combination of these two vectors, you're going to get this vector here. All right, so how can I use this information? Well, I know when I multiply matrix by a linear combination, that gives me a linear combination of the matrix multiplies. So that's the same thing as 4 times A inverse of times 1, 0, 2, 0 plus 5 times A inverse of 0, 1, 0, minus 1. Okay. Now, what's A inverse of 1, 0, 2, 0? Well, it's up. You don't see it now, but it's up there. What's A inverse of 0, 1, 0, minus 1? It's 3, 4, 0, 1. So I'm just going to go ahead and replace this. This one is going to be, this part here is going to be 5 times, whoops, lost it again. 5 times what? 5 times this guy here, 3, 4, 0, 1. That's the second term. 5 times 3, 4, 0, 1. And the first term here, this 4 part, 4 times whatever this was, I'll have to look up and see what it was. As soon as I get that, I can make the linear combination and get my answer. So inverse of 1, 0, 2, 0 was 2, 2, 1, 1 right here. Okay, so I'll put 2, 2, 1, 1. Okay. All right. So, let's do it now. How do you do this? It's going to be 4 times 2 plus 5 times 3. That's 8 plus 15. We'll just do it out like this so we don't make a mistake. 4 times 2, 8 plus 20 is the second one. 4 times 1 is 4 plus, what was that? A 0. So that's 0. That's good. And then here we have 4 plus 5, and we get our answer 23, 28, 4. And 9. And that's our final answer right there. All right. So the takeaway there is, again, matrix multiplied by a linear combination is the linear combination of the multiplied results. And that makes this problem pretty straightforward. All right.